again, I think I'll never get used to that. God. I'm sorry. Increase the size of the full screen. Okay, don't do full screen, but increase the size. I'll try. And there's something bothering me. I'm doing it videos, and are you seeing the last one? Did you see video or not? Okay. Full screen. Okay. I will not do full screen. I will increase. All right. Let me increase.
Thank you, Doctor.
Okay, it's okay, but I cannot do anything. Now I know, so, okay, I will continue, okay? So, so I was saying that we had the, oops, tick share. So we had the direct imaging as if we are observing with pictures. I take the picture, but it is not that efficient when it is so far, because the light of the star will completely erase the light of the planet. So what do? We do actually what we call coronography. What is the coronography? It's when you are at home and you have someone enters your bedroom or the saloon or something, and he or she puts the light on your eyes. So what do? You do a coronography without knowing. You do this. You know, what is that? You know, like I did now. It is you are trying to erase the light of the star to be able to see the face of that person. So this is what happens when you do it. You erase to do the contrast of the exoplanet that it is near the star. And the other way to do it, which is really very highly efficient, is the transit. So the transit is, for example, a very well-known transit since ever is the eclipse. Eclipse is really excellent. Because we have the sun, we have the moon, and it is transiting the sun. And we have other transits also. The transit of Mercury, the transit of Venus. Any transit means that something transiting in front of a source. And this is a method that it is used, but it has something that we have to take it into consideration. We can observe a planet that is transiting in front of a star if it is somehow in a line of sight. Okay, imagine that we are on Earth and this is the star and the planet is like this. We cannot determine if there is a planet or not. So it has to be somehow in one plane. But we can see the dimming of it, and we can know when it's go down and when it's go away. So the dimming will tell me the time of transit, and the dimming, the height of the dimming will tell me the size of the planet. And moreover, we are going to use the transit to study the atmosphere of the planet, if there is any. And we're going to determine if there is an atmosphere, the composition of the atmosphere, and to search for what are the reasons and the building blocks of life. So those are the important methods. There is one other method that Einstein thought it is impossible to have it, which is the gravitational lens. So the gravitational lens is a little bit complicated, and I think that you will not see if I will do the video. But basically, it's like if you have a loop, when you have a loop and you are reading, okay? So the sentences, the letters will stay always small on the paper, okay? So you're having this, you have your loop, it's written very small. But what's happening is the light that is coming from the book passing by the loop will arrive to your eyes magnified. This is exactly what's happening with the microlensing, gravitational microlensing, but instead of having a loop, the gravity will play as a lens. So if you want to observe something very far, you have a gravity, something very heavy, it will increase the light that comes to you. Fake magnification. So this was discovered by Einstein, and he said it's really impossible to observe because we have to be completely in a straight line, you see? So to be able to do this, we have to be the observer here and the target here, and the big bulk of a lens, gravitational lens, has to be here. And we are observing a lot nowadays. So those are basically the important points that we have we have to observe exoplanets. And believe it or not, we have a lot of new fancy things and weird things we observed. And from those that we observed lately, and this is a art vision, Ahmed Jabakanji. I pronounced it well this time, yes, of Kepler 186f. This is an exoplanet orbiting a red dwarf. It is the first time that we observed an exoplanet that has a radius similar to the Earth. But hey wait ما تفكروا هلا قلتوا يا سارعين رايحين عليها لما يفتحوا المطارات. No, it is 582 light years in the constellation of Cygnus. So what you're seeing, the red one, the red point is the red dwarf, and the planet here, the big one, is the small one, and it's 186f. And just to let you know the notation, when we name things in exoplanets, so Kepler is the satellite to observe it, 186 is the name of the star, F is the number of planets, A, B, C, D, E, F. So you may know by now that minimum this red dwarf has 6 planets around it. So a beautiful solar system. So now. Great. We discovered, we developed, we are happy. Dr. C said, yeah, we have a lot of exoplanets. Where are they, our friends? If you want to think about aliens and extraterrestrial life and whatsoever, which one you prefer? You prefer the avatars, the blue ones? You prefer the les petits gris, the small gray ones? You prefer ET? Well, none of those. Let us think about life and possibility of having life, right? Well, Drake's formula were developed and were studied and updated, but I will start with that, right? What is Drake's formula? Taking into consideration that forming planets is very easy now. Forming star is really easy. So we have like 200 billions of stars in our galaxy. If we take that, half of the stars have planets. And if we take that, we have 100 billions of galaxies. So I'll take you do the math. And we end up by n is the number of possibility to have life is equal L square. Is equal to R stars, which is the formation rate of stars, times FP, which is the fraction around the fraction of formation of planets, times N, it is the number of formation of planets that may have life, times multiplied by FV, which is the number of fraction of, I just want to put it in front of you, the number of planets that may form life, times FV, fraction of planets that have form of life, smart life, times F, life that have technology, times T, time of longevity. شو يعني؟ يعني to be able to have n number of elsewhere extraterrestrial life, we need to have a star, a planet, development of life, development of smart life, technological one, and T, time to longevity, to have time to develop, right? So all of those, if you put the formation rate of stars, it's definitely very big. The formation rate of planets around those stars, it's definitely very big. The number of planets that they are terrestrial is definitely very big. The number of planets that they can have life is definitely very big, and I will come back later on. The number of planets that they can have life and they can develop smartness, intelligence, is definitely very big, because under one condition, that TC is available. Because nowadays we think that the more we become technologically developed, the more we are a threat to life. So if we put all of this, N is not zero. So the possibility of having life elsewhere is not zero. But what are we searching for? Are we searching for the green? Are we searching for the gray? Are we searching for the monsters? Are we searching for the blue? So the latest studies, and I will finish with that, we are going to search, as I told you, with the transit method. We will know, and the radial velocity, we will know if it is a terrestrial one, so we can work on it. If it is a gaseous one, we will not go to search for life in it for now. So if it is a terrestrial one, we need to see colors. We need to see if there's an atmosphere. Why if it is an atmosphere? We have to see, because we are going to search life based on what we know. Carbon, hydrogen, oxygen, nitrogen, and hydrogen, I said, sulfur, sponge, phosphor also. So SPONCH. So this is why, by the method of transit, we will see if there's an atmosphere, and if there is an atmosphere, we are going to see if there's oxygen and water. So if there is oxygen and water, we are going to see if there is H2COH, if there is sulfur, right? And after, we are going to see the color. What is the color? Because on Earth, the photosynthesis will turn the Earth green, means that there are plants. We need to see what kind of plants, if any, exist on other planets. So you see, one, we need to see if there's an atmosphere. Second, we need to see if there is colors. Third, we need to see what is, if there is water. Third, we need to see if there is colors. And fourth, we need to see if there is a signal that is repetitive with a meaning. And this is what we are searching for, intelligent aliens. For the moment, the intelligence, we didn't detect it, and every other thing that you can read on the net is wrong. This point of H2O, we detected. We detect also building blocks of RNA in the interstellar medium, and not just even on planets. And we're searching for signature of life and biosignature. And maybe next, the third part, we will talk about what is life and how we develop cells. And for now, I will stop, and time for questions. Thank you. The floor is yours.
Doctor, I had a question.
Go ahead. Go ahead. أهلا وسهلا.
Doctor, but can we just compare our solar system with an atom with a infinitely large thing?
No, it was this error was made since Bohr's model, but nowadays we know that with the electronic and nuclear telescopes that the atom is not absolutely made like this. The atom, when we go to the atom level and we go down, we know that it is question of probabilistic Schrödinger equation, possibility of existence of the electron, and it's not just a simple radius that is rotating. I hope I answered your question.
Yes, yes. Thank you, Doctor.
You're welcome.
Hi, Doctor.
Hello, Tatiana.
كيفك؟
Great.
I have a small question, please. بدي أسألك عن ال conservation of energy بالuniverse، كل اليونيفرس. بدي بس هيك شوي لأنه عم بفوت عم نبش يوتيوب وجوجل وكل شيء، so شوي lost يعني لأنه في كل واحد يحكي شيء وهيك، so ما في جواب دقيق عن هذا الموضوع. فإذا
وليه عم بتفتشي على جوجل؟ تعي على ليتس جراديويت ودكتور سي. ليش بتروحي على جوجل؟
يلا ما جيت.
بس what question you want to know about conservation of energy?
بدي أعرف exact لأنه عندي project باليونيفرسيتي هلا الأربعاء مفروض نقدمه، so بدي أعرف يعني how it works، إنه كيف بيكون تيضلوا ال conservation of energy since the Big Bang till now.
هلا إذا بدك تحكي عن اليونيفرس ككل I cannot tell you that it is completely conserved لأنه we have we have
exactly the question.
ليكي هلا أنا ما رح فوت تفاصيل هون. بطلب من فرح it will be very developed لأنه نحن هون بنضل outreach. إذا بدي أحكي عن الانتروبي which is the negative energy anyway, so العالم بتصور she will be هيك mislead. اوكي ما عندي انا اهلا وسهلا فيك نفوت بالانتروبي والانرجي وكيف الانرجي is conserved on a scale and is not conserved on another, you know. اوكي لان في عندنا الماتر والانتي ماتر and for a reason that we don't know طلع الماتر اكثر من الانتي ماتر. This is why we exist. So بحكي give her please my او ليكي انت عندك هنا على انستغرام.
Exactly.
Okay, so اكتبي لي واعطيني your email وبنحكي اللي بدك اياه and you will have a great project.
Okay, thank you, dear. Merci.
Any question?
Yes, I have a question.
Yeah, go ahead.
Okay, my question. Safe.
Yeah. Hello مهندس. Hello باش مهندس. اهلا وسهلا.
يسلمك. الله يسلمك.
I'm a rocket scientist. Yes, go ahead.
Okay, my question is إذا كان في أحد من العلماء ما يؤمن بالبيج بانج، يؤمن بالستاتيك يونيفرس أو الكون اللي بدأ موجود من أول، هل العلماء الآخرين يكونوا ينظروا له بأنه نظرة دونية إنه هو ليش ما صدق بالثيوري of Big Bang؟
Of course it's ما فيك تآمن بالستاتيك يونيفرس لأنه الأوبزرفيشن مع الإكسبانشن of the supernova، الإكسبانشن of the galaxy، الكوزميك باك جراوند ديتكشن، يعني هن عندنا observations هلا لما طورنا الساتلايتس والديتكتور والobservatory we have observation that prove us انه في شيء ما تسميه بيج بانج اذا بدك، سميه شيء وفلت، الانفلات الكبير. في شيء كان ملقوط وفلت، في شيء كان حامي وفلت. يعني we are able to observe now a temperature like a remnant of what happened 13.8 billion years. And this temperature لو كان الكون static ما كان إلها لزوم تكون موجودة. We are also able to observe galaxies عم بيبعدوا عن بعضهم. and we are always also able to observe stretching of some places in the universe. يعني هيدا الشيء ما كان بيكون موجود إذا كان اليونيفرس static من أصله.
تمام. Thank you.
You're welcome يا أهلا. Any other question?
Yes, doctor. I would like to ask you about the full moon.
مين عم بيسألني؟ ماني شايفة أنا شيء. هيدي فرح؟
Yes.
عرفتك من صوتك.
Yes.
عن الفول مون هلا اللي صار.
Yes. What is
okay.
the concept behind the full moon and what impact it has on us, on our planet, and is it really pink?
Yes. هول الفول مونات مهضومين لأنه you know شي مرة بركي بنعمل عن الفول مون والسوبر مون وهيك. actually every month في عنا نيو مون وفي عنا فول مون، ومثل ما انه دوران القمر هو بيكون هلال وكامل وهيك. بالزمان بالاقدمين هن مثل كانه مثل عادات بسموهم الفارمرز وهيك. كانوا بكل موسم بسموه شيء.
Many of the moon's nicknames date back to the early Native Americans.
كانوا كل موسم بسموه شيء. مثلا اذا بتتذكروا في عنا سوبر بلو مون وفي عنا الولف مون، في عنا الريد مون. لما يبلش الربيع اول فول مون بالربيع بسموه البينك مون. والبينك مون ليش؟ لانه بيطلعوا الورود بالربيع، بتبلش الازهار تتفتح وهيدا بس يعني ابدا هيدا الخلاصه تبعه. والفول مون هو ما بيأثر على الإنسان إلا إنه بيأثر على المد والجزر لأنه بالجرافيتي بالجاذبية. وبعض العلماء البسيكولوج والكريمينال بأمريكا وبأوروبا بيقولوا إنه في شغلتين بتصير على الفول مون. إذا كانت المرأة الحامل بشهرة قريبة من شهرة بصير في ولادات أكثر لأنه بيأثر على المياه. واللي بيكون عنده مرض بدماغه وبياخد أدوية كتير بيتأثر بليالي الفول مون لأنه بيكون القمر، وخاصة إذا كان سوبر مون يعني بيكون بأقرب نقطة للأرض وبيكون بدر. وفي نقطة ثالثة كمان، العالم اللي بتكون تعمل كرايمز من شي 7 سنين كان في بيبر طلع وقتها بأمريكا قالوا إنه شو بيقولوا البوليسمان بيحطوا statistics إنه في أكتر كرايمز على الفول مون، بس إنه أسامي المونز لا هن بس كرمال لأنه هذا الشهر وهذا الشهر. هلا أوقات بيسموه أج مون كمان بأبريل لأنه بيكون مساقب مع الباك عيد الفصح عند الطوائف المسيحية. فوالا، ما بعرف إذا جاوبت على سؤالك يعني.
Yes, أكيد. Thank you.
يا أهلا وسهلا. حدا عنده سؤال بعد؟ طيب لكن بنقلكم باي باي.
باي دكتور كتير.
يا أهلا وسهلا فيكم. ثانك يو لليو اس جي وليتس جراديويت وناتالي تيا ثانك يو سيشنز تيا. ثانك يو نعيم. واكيد يمكن نحن رح نكون الجمعه الجاي وان شاء الله من بيروت اكون انا رجعت على لبنان.
توصلي بالسلامه.
Thank you so much. Thank you. فرح جاني ميرسي بوكو على حضورك وبدك تعلميني لظبط البينتينج تبعي. ثانك يو دكتوره مهنا. ميرسي بوكو ناتالي. مدام فرح.
Yes,
عشان ريزيوم نخلص. ميرسي باي باي. وبنحكي sessions. Tatiana, have my contact, okay?
Thank you so much.
أكيد
Thank
أكيد
you so much,
يلا.
Doctor.
Thank you so much.
فرح أنا وياك نرجع.
أكيد.
Ciao. Bye bye. Thank you. Thank you for having me. Bye.